All right, so it says, given standard form, let's talk about why this is in standard form for the moment. That's probably important to remember, or remind ourselves. It's in the form ax squared plus bx
bx plus c.
plus c. We like it to equal 0 sometimes because we can solve it when it's equal to 0, but it just has to be everything on one side of the equation. And that's what I'm seeing here. This looks good to me. Okay. Do you remember from the other night what the y-intercept means for x or y?
Where they hit 0, or where it
One
hits
of them, yeah, one of them is 0. Which one is it? Do you remember from the other night?
the x.
X. Yep. So x is 0.
Right.
The y-intercept means x is 0. This is really asking you to find f of 0. Could you do that for us, please?
Yeah. Is this -1/2 or?
So you're putting 0 in for x, right? Wherever you see an x, you're replacing it with 0,
Crap. Okay, hold on.
which
All
will
right.
likely change your answer.
$18.
All right, I'm hearing numbers I don't like. 0 squared, 0 to any power is 0. 2 times 0 is
0.
0. This whole thing is 0.
Oh, the whole thing. Okay, right.
Plus, what is 8
Plus a
times
whole
0?
nother 0. Yeah.
Yes.
Okay. So it's really 6.
Yes, and it happens to be that last number. Is it always that last number? I mean, sometimes, depends on a few other things, but yeah, I mean, that's a reasonable thing to, remember if you want to shortcut it a little bit. Okay. What I would like us to do is to solve this by factoring first.
Okay.
Okay, we will complete the square, but I want to solve by factoring first. So the first thing you might do when you're solving by factoring is you look for a number that goes into all three terms. Is there a number that goes into 2, 8, and 6, divides each of those evenly?
2.
Divide by 2.
Yeah.
Okay. Now you don't actually remove it. You just put it on the outside.
Okay. Put it on the outside.
So what, yeah. So what does that become when you,
X plus, or wait, do I like?
you're just dividing the number. You're not changing the X.
Okay, so 1x plus 4x.
It's not 1x though. What about this 2 right here?
Oh, squared.
Yes. Yes. That's very important.
Okay.
Plus
4x.
Good.
3.
Good. Okay. Very good. Now from here, this is a certain type of factoring. Okay. And that factoring is you're looking for two numbers that multiply to 3. Okay. But they also have to add to 4. Multiply to 3, but add to 4. Any idea what those two numbers might be?
3 times 1.
Yes. So this becomes x plus 3, x plus 1 equals 0. And you still have the 2 on the outside there.
Got it.
All right. So to solve this, you set anything with an x, any terms with an x equal to 0. So you're going to set x plus 3 equal to 0, x plus 1 equal to 0.
Okay. Got it.
Okay, so now could you solve each of those for us, please? Tell me what the x value becomes to make it 0.
X equals -3, X equals -1.
Sorry, one more time.
X equals -3, X equals
Okay, okay,
-1.
good. Yeah, okay, I wasn't sure if I heard it, so sometimes go for a repeat. Okay, so process, right? What's the process? Well, we took a 2 out because a 2 went into everything. Then we factored the inside. I want to spend a little more time on this type of factoring. I think that could be important here. But let me throw another one at you and see if you can factor this. Okay, it's kind of like the last one. There is no GCF. There's no number that goes into it. It's just a straight finding two numbers that multiply to 8 but add the 6. So take a moment and see if you can solve that. I'm going to step away for about 10 seconds, but I'll be right back. All right, I am back. Let me know if it's clear what we're trying to do here.
Yeah, I got an idea. All right, got it. X plus 2, X plus 4, or X multiplied by 2 in parentheses, X multiplied by 4.
There's the operator is plus 2, x plus 2.
Yeah, okay,
It's not x times 2. It's
got it.
that. Now you got to keep going here. What did we do in the previous problem once we had these
You
binomials?
gotta
These are
make
called
them,
binomials.
you gotta put 0 on the other side, equal it out.
Yes. I'd like you to do that and figure
X
out the.
equals -2, X equals -4.
Okay, very good. All right. Now, this is a perfect problem for us to learn how to complete the square, and then we'll go back to the previous problem or two. So we're going to now solve this problem by completing the square.
Okay.
CTS, completing the square. And I don't know, the analogy I always make is to like tools in your toolbox. There's sometimes more than one tool for the job, but there's sometimes the right tool for the job. Completing the square is a pretty specific tool. It's not like one you would use all the time, but it does work really well in certain situations. I'm not saying this is a great one for it to use, but it does work out nicely. That's why we're going to use this one. All right. So here are the following steps for completing the square. You first move any constants to the other side of the equation.
Right.
And you write x squared plus 6x, leave a space, equals -8. And then I'm going to put in a box here, or a square, if you will. If you believe that's a square.
Mhm.
And our goal is to fill in the square. We need to figure out what goes in the square. So to do that, you actually look at this middle number here and you divide it by 2. What is 6 divided by 2?
3.
3. Then you take that number that you divided by 2, 3, and then you square it.
Right.
What is 3 squared?
9.
And that's what goes in the box here. And to be fair, you have to do it to both the left and the right side.
Both sides.
Both sides. That's why I put a box in both places to indicate, hey, we're going to put it in both. All right. Now, on the right side, you add.
+1.
+1. And then I'm just going to kind of reframe the problem here where it's x plus 3 squared equals 1. And you do know enough to solve something like this. We've done a bunch of these, but maybe it's been a while. Do you remember what to do from here to solve for x?
Yeah, do the square root.
Yes. But when you take the square root of the right side, it's plus or minus the square root.
Right. The square root of 1 is 1, or
Yes, plus or minus 1. And this is where you have to write two equations. X plus 3 equals 1. X plus 3 equals -1.
got it. All right. I got that.
Got it?
Yeah.
Okay, what are the two x values?
X equals 1 to x equals -1.
You have to undo the +3 on both
Oh,
of them.
oh, my bad. X equals 2, x equals -4.
When you subtract 3 from the one on the left, I get a different result. You have $1, you owe someone $3.
+2.
When you give them your dollar, you still owe them. You still owe them $2.
-2.
Yes. Okay, so I wouldn't say that any of this. There's no one step here that's really all that difficult. It's the combination of steps. It's the fact that it's like, okay, I got to move this over. You move the number over. Then you got to figure out what to fill in this space, which really isn't that hard. I mean, you can divide by 2 and you got to square numbers, no big deal. Then you have to take a square root of both sides. You know how to do that. Then you have to separate it into two equations and then solve. None of that is hard on its own. It's doing it all together that's difficult. So let's look at another one together. X squared plus 12x. And let's do plus 32 this time. Right. So first step is to move that 32 to the other side of the equation.
Right.
Okay, so it's x squared plus 12x, leave a space. We want to fill this in. We want to fill that in. Figure out what to fill in, you go back to look at the middle number.
Middle number divide by 2. So that's,
Yes,
and then the square root of 6.
square of 6.
36.
Okay, so in both boxes, you get a plus 36. On the right, it becomes +4.
Right.
Why don't you try solving it from here?
Wait, would the 4 squared go down to 2?
Let's look back at the previous problem just to make sure here. What is this symbol here?
Plus or minus?
Square root plus or minus, right? So
Mhm.
yeah, it is the square root of that number, but then there's also the plus or minus
Okay.
to add in there.
X equals -4, X equals -8.
Those are correct. Good.
Nice.
All right. Okay, so here's another style of problem that you might see. Let's say it's something like this: x squared minus 6x minus 7 equals 0. Okay, so really the only difference is I've added some negative signs. You still complete the square the same way. You add the constant to the other side of the equation. Okay. You still take half of this middle number. Okay, now this time though, it's -6. So half of it is
-3.
-3. Okay, so whatever operator you have here, whether it's plus or minus, that's what goes here.
All right.
Now, when you square a negative,
+9.
+9. Okay, so on the right-hand side, you get 16. We like that. It works out nice. Meaning you can take the square root of both sides.
Square root of 16, 4.
Yep. So go ahead and solve this from here, please.
X equals 7, X equals -1.
Doing great. So now let's do go the full circle here. Want you to try this one on your own, start to finish. It's not impossible. Let's go. Get the right numbers here. Let's do this. Okay, so I want you to solve this start to finish, completing the square on your own, and then we'll get back to the one that you have.
X equals 8, X equals 0.
So just looking at it, I can tell you that 0 is not correct because 0 squared minus 4 times 0 is -12, doesn't get you to 0. Did you write x minus 2 squared in parentheses?
Well, let me see where I messed up.
And if you did that, then we got to check the number on the right.
No.
Okay.
Wait,
again, you
yeah.
gotta-
Yeah. And then that equals +4.
Yes.
Yeah.
Okay, so this is good. So you take a square root of both sides. It's x minus 2 equals plus or minus 2. But that isn't right either. Okay, what's going on here? No, it's not 4. I'm sorry. It's because you add the 12 to both sides,
Yeah.
and then you add
16.
the 4. It should be 16 on the right.
Yeah, I have 16.
Okay, so you have to take a square root of 16. Square root of 16 is 4. So you have x minus 2 equals 4. X minus 2 equals -4.
So +2 x equals 2.
Adding
X
2.
equals positive 2, x equals negative 2.
On the left here, it's 4 plus 2, that's 6. They're both positive. On the right, it's negative 2.
Let's see.
Okay, let's try one more. Yep, for one more?
Yeah.
Okay. Okay, give this one a try, please.
What would 11 squared be?
Tell me where you're getting that number from.
Because I don't even think, okay, so -8.5 is -4.
Right. So like here's what I've heard, and that's all good. That's x minus 4, like that. Now you
Yeah,
square the 4. So I'm not sure where the 11 is coming from. You're squaring 4.
so it's 16.
Yes. Yes.
16, okay, my bad. So on the right-hand side, it's really 1.
You got it.
One squared is 1, so
Square root, right? Plus or
Mhm.
minus. Yeah. Square root.
x equals 5, x equals -3.
That close. Maybe that is right. Sorry, let me check here. It's these are hard to do without separating them. Yes, you got it. 5 and -3. Okay, or +3. Okay. Kind of your choice if you want us to do any more of these. I mean, I wish I could say for sure you'd have it on your test, but to do the one that they have in your review packet, it's it's like what we've been doing, just a little bit more difficult. You mentioned taking some baseball lessons. Really, when you take any lessons, no matter what sport it is, or anything you're trying to learn that's new, there's kind of a limit. Like there's like 3 things you can remember, but if you get to the 4th thing, it's just too much. And that's kind of what the problem is with completing square. It's like more than 3 things, more than 4 things. And that's why it's like, well, am I dividing, squaring, adding, square rooting, like lots of things to do. That's why most students struggle with it. So I totally understand your pain, your frustration with this, but new problem nevertheless, to solve by completing the square.
Mhm.
But you'll notice that the way I solve this is exactly the same way as before. You move that constant term to the other side.
Okay.
Okay. Now, the way I do it is a little bit different than what maybe you saw in class. I'm still going to draw these boxes here and this box here. We're going to fill that in. But the next step on the left side here, it's a little bit different. We don't just take half of this number. Okay. And the reason is because there's a 2 here.
Mhm.
So what I do is I show it this way where I factor out a 2 from everything, including that number that we don't have.
Mhm.
Okay. But now what you have inside here is just like what we've been doing. Like, you know how to complete the square with this.
Yeah.
What is half of 4?
2.
2 plus 2 squared. Okay. So you divided by 2 to get that 2. And then what do you do to go back into this position?
Square it.
Square it. So that becomes plus 4. And
Right.
what you're used to is writing plus 4 on both sides, but it's not in the red box. Now, to get back to the red box, this is the additional step here. If you multiply the 2 in each of these, 2x squared, 8x, 4, you see how 2 times x squared gets you back to the previous line, 2 times 4x gets back to the previous line.
Yeah.
Well, 2 times 4 is going to be the value that goes in the box.
8.
And that's what you put on both sides of the equation. Yes.
So on our other side, on the right, it comes out to 2.
Comes 2. Yes. Now this is, and then you have to bring this 2 down, but you've almost got it. Okay. The difference between this and the previous problem is that we're not solving. We're just completing the square to write it in vertex form. So instead of taking a square root or moving something around, this time you actually move the 2 back by subtracting 2 from both sides.
Let me see.
And then you rewrite it as f of x equals.
And that's the final version.
Yeah, that's the vertex form that they're looking for.
Okay.
Right now, I'd really like to move to another page, but I guess unfortunately these are all the same. Okay, we'll just keep going on this. All right, now that in terms of like where we are on the page, we're up to the point where it says completed square and the vertex.
Yeah. What's the actual completed square part?
Well, I'm taking a bit of a guess, but I think it's everything we just did there.
Okay. And
This is
the
this is
vertex
sort of
is the same as well, or what?
the vertex comes from this.
Okay.
So it comes from this. So like, let me give you some examples here. Let's say that, and we'll come back to that. Let's say it's x minus 3 squared plus 5. The vertex would be 3 comma 5. But
Okay.
if I tell you, if I give you a different problem here where I say that's x plus 4 squared minus 2, the vertex is minus 4 minus 2.
Mhm.
And what I want you to notice about these two examples is that the constant on the right is part of the vertex as is, but inside parentheses, it's different. See how when it's minus 3, it becomes plus 3. When it's plus 4, it becomes minus 4.
I see.
So going back to your problem, you have to remember this, that it's basically opposite inside, but then the other number.
It's positive.
It's positive, so it becomes negative.
Right.
So that's -2, comma, and then you keep the number on the outside.
-2, comma, -2.
Yeah,
Can't be the same, or it can.
it can be the same.
So -2, -2. Got it.
One of the things that really makes it tough for you as someone trying to learn this is your instructor keeps giving you the same equation over and over again. And really, you want to do like we did, clean the square with a bunch of different ones to learn it, not to keep reusing the same equations, doing different things.
Yeah.
But we can't change that. So believe it or not, we already did the factored form earlier. So I'm just going to give that to you.
Factored form. Okay. Oh,
If
right. I
you want to
remember
look,
doing that.
well, we actually already have the x-intercept. The x-intercepts are when you set this equal to 0. So you have to solve each of those,
So the
and you did,
x equals -3, x equals -1.
yes. So if you need them as an ordered pair, it's -3, comma 0, -1, comma 0.
Got it. And then a graph.
All right, so now a graph. So we've kind of gotten a long ways away from the graph stuff, but let's do this. We should make a table like we were doing the other night.
Yeah.
And I want, or the other day, sorry, it wasn't night. Let's use the vertex form of 2 x plus 2 squared minus 2. So I want us to do this in a table, x and y, -2, -1, 0, -3, -4. Okay, now we already have the vertex. But we
So,
have to evaluate at each of at one of the other points here. So we'll say -3 and -1.
so plug in the -3 for x.
Yeah, or the -1.
Okay, I'll do -3. -1 squared is 1, right?
Yes.
2 times 1 is 2, -1 is 1.
You're doing -1, is that right?
No, -3.
-3, okay. Okay. What is the output of that? What does that become?
-1, or just 1.
Let's go back and look though. Didn't you say your x-intercepts were -3, 0? Meaning that when you put -3 in for x, it should become 0.
Yeah.
So let's take a look at that. You were right. -3 plus 2 is -1. -1 squared is 1. 2 times 1 is
2.
2. -2 is,
Oh, I had 2 minus 1. So 2 minus 2 is 0. Yeah, I got that. Okay, that makes sense.
okay. And then you can do the same thing for -1, but you may want to leverage symmetry. You may want to say, okay, I don't need to check that point because it's going to be 0 because of symmetry or the fact that you already have it up here from the x-intercepts.
Mhm.
It's up to you.
So 0.
All right. And then you got to check either -4 or 0. I'd recommend 0, but that is your choice to way you want to go.
Yeah, I'll do 0 real quick. 6.
So what will -4 be?
-6. Or just 6.
Just 6. Yeah, it doesn't change sign. It's the same number. Okay, could you attempt to graph this?
Mhm.
It doesn't have to be super accurate, just can't be sideways or upside down. It's got to be the correct orientation.
Got it. All right. Domain would be all real numbers. And the range should be y is greater than 2.
So yes, the domain is y greater than or equal to, but it's not 2. It's the
-2?
y value. Yes, it's the y value of the negative of the vertex. Good. That's the range. The domain is everything. All right. Now, I think the question asked, I didn't snip that in. I believe it asks you to determine the vertex, which we have. It's -2, 2, -2, -2. The y-intercept, which you have 0, 6. The
Mhm.
x-intercepts, you have to label them on the graph -3, 0 and -1, 0. And then you've done the domain and range.
Got it.
All right. I'm going to suggest we go to 11. I think we can finish page 11, or at least do some stuff on 11. Whereas 10
Yeah, that sounds good.
could get sideways on pretty quick.
Okay.
All right. All right. Number 11 starts out by saying, graph the functions using transformations. So the first thing is you have to decide, well, what is the parent function? So when you look at the function here, you have to say, oh, something stands out to me. I've seen that before. It's a blah, right?
Mhm.
It's like when you step up to the plate and you see the pitcher, he throws a pitch and you're like, oh, that's a fastball. It's a
Right.
slider. It's a curveball. It's a pitch clock violation. Whatever it is, right? So what do you see in here? What stands out to you?
The x squared.
X squared. And you don't need to know the name. You don't need to know that's a quadratic. Maybe we'd like you to know that, but you have to say, okay, it's an x squared. And then probably more important than that is, do you remember the parent function table for a quadratic? Do you remember the 5 good points?
For the y's.
Yes. Yes. And if you're not sure, let's just calculate them now.
Yeah, I guess we have to. Yeah.
Okay. So I'll let you do
Well,
that here.
it'd be 4,
Okay. Good.
2,
Nope.
or 1,
Good.
0, 1, 4.
Good.
Got it.
Okay. So make a quick sketch of that on the left there. You can say, oh, I've seen that a bunch of times in this class.
2, 4. Got it. All right.
All right, now we're going to do the transformations. And first we're going to talk about what the transformations are. There are 1, 2, 3 transformations. Can you give me any of them? Can you give me any of the 3 transformations that you see?
a negative
Okay, but tell me what it does. Like, what does that negative do?
down 2.
The up or down is this number on the right.
To left 2.
Only if it's in parentheses. Parentheses is the left or the right.
So the -2.
How about this +5? Is that up or down?
Up 5.
Up 5. Okay. The 2 is a vertical stretch by 2.
By 2, right?
The negative is a reflection
Over that.
over the x-axis.
Okay.
All right, so we're going to deal with these one at a time. So we need this table. Grab the table. And then we're going to look at the transformation. Okay, and the first transformation we said was a vertical stretch by 2. And what you have to know is that that affects the y value.
It gets longer.
Yes, so you multiply all the y's by 2, x's stay the same. 8.
0, 2, 8.
Yes. And if you were to graph them on top of each other, you would see like a string pulling it up each time. But you have to be able to graph. Oops, those are wrong.
Got it.
Is that okay?
Yeah, that's good.
Okay, so the next transformation we talked about is I do like the list. I would actually make you do the list here. Is the reflection on the x-axis, but it's like, well, what does that affect? Does it affect the x or the y?
The X. No, the Y, because it's
The
flipping.
y. Yep, still
Yeah.
affects the y. In fact, it just negates the y. No change on x.
Got it. Big change on X. All right. And then the up 5.
Did you graph this,
Yeah,
by
I
the
did.
way? Okay, yeah. And then what does that do? Does it affect the x or the y?
It affects the Y.
Affects the y. You add 5 to every y value. So when you do enough of these, you're like, oh, I'm gonna just do it all at once.
Huh.
And you really can. Right now,
Yeah.
you feel like that's impossible, but you really will someday be able to.
All right, I got the final point.
Perfect. And then go ahead and graph it.
Yeah. Yeah.
Okay, so in just the short amount of time we have left, let's look at another function and just talk about the transformations. So let's say it's x minus 2 squared plus 5. This has 2 transformations. Can you give me either of them?
Up 5.
Okay, that's the second one.
2. Yeah.
And this is always opposite of what you think it should be. Like normally the negative would mean left. but because it's opposite of what you think it's actually to the
Right,
right too.
right, too.
All right, let's see if we can do
First
one
one
more.
is right two, and then
Yes,
down
up 5.
Okay.
All right, let's say it's f of x equals minus x squared plus 3. This has 2 transformations. Can you tell me either of them?
Second one is up 3.
Okay,
First one is to the right 1.
yes. No, I'm sorry. This negative. Sorry, we're looking at the negative, not the number. Just the negative.
To the. Wait, then what does the negative do? Does it negate it or flip it?
Yes, reflect over the
Yeah,
x-axis.
Okay.
Okay, great. All right. All right, we are all done for today. Great job. Go ahead and stop.